Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 16, 2025, just yesterday. The big result is a simpler training recipe that boosts reasoning performance, improving average MAJ at 32 by plus 3.4 percentage points over GRPO, with standout gains like plus 7.3 points on BRUMO 25. The paper is titled Single Stream Policy Optimization, and the implications for model training are quite significant. This paper proposes a single-stream approach with the persistent KL adaptive value tracker, global advantage normalization, and prioritized sampling, which delivers smoother convergence, higher throughput, and fewer wasted updates from degenerate groups. So the figure contrasts how group-based training and single-stream training compute learning signals. Figure 1 shows that GRPO splits one prompt into many responses, normalizes rewards within a group, and often produces zero advantage when outcomes match. The lower diagram simplifies the path to one response per prompt, which then uses a persistent value tracker to form a stable advantage. This matters because a steady baseline lowers variance and removes synchronization stalls. So the last figure contrasted training flows, and this table reports the payoff in accuracy. The table shows that single-stream policy optimization outperforms GRPO across 5 math benchmarks, with the average MAJ at 32 reaching 63.8. Majority at 32 means the model tries 32 solutions and the most common answer counts, which reduces randomness from any single attempt. Gains are largest on BRUMO 25 and AIME 25, so the method improves both hard and mixed difficulty sets. So the last table reported headline accuracy gains, and figure 2 shows why the gains persist across sampling budgets. Pass at K rises steadily, and single-stream policy optimization stays above GRPO for every dataset and every K. Pass at K means the answer counts if any of K attempts is correct, which rewards consistent reasoning. The orange lines sit higher with similar slopes, so the advantage holds rather than relying on one-off spikes. The average panel confirms a uniform margin at K equal 8, 16, and 32. So the last figure established consistent gains, and figure 3 explains the mechanism. Single-stream policy optimization wastes far fewer updates and delivers steadier learning signals. The left panel tracks how often groups are degenerate, which means every response in a group has the same outcome, so advantages collapse to zero. The blue line stays high for GRPO, while the red line for the single-stream stays near zero. The right panel shows advantage variance dropping with the persistent value tracker, so gradients stay stable during training. So the last figure showed steadier learning signals, and figure 4 illustrates why group-based sampling stalls throughput. The left panel depicts a low variance group where completion times cluster tightly, so the group finishes quickly. The right panel shows a high variance group where a few very slow samples gate the whole group, which forces idle waiting and waste compute. This bottleneck explains why a single stream avoids synchronization delays and trains faster. So the last figure highlighted why stragglers stall groups, and figure 5 quantifies the throughput impact. The left panel shows group-based runs gated by the slowest group, which pushes completion to about 486 seconds. The middle panel illustrates group-free sampling that selects the fastest individual samples, so the batch finishes in about 112 seconds. The right bar chart summarizes a 4.35 times speedup, demonstrating why single-stream training sustains much higher utilization. Alright, 2 takeaways stand out. Single-stream training with a persistent KL adaptive value tracker gives a stable, low-variance learning signal, and going group-free removes synchronization stalls, yielding higher accuracy and a 4.35 times throughput boost. The broader implication is simpler RL recipes can scale reasoning better than complex workarounds. That is it for the AI Research Roundup. I am Alex. Thanks for listening.